Hello guys, welcome back to my YouTube channel. I am back with another video of data science. Okay, so in this video we are going to learn about name-based classification. Suppose you are a product manager and you want to classify the customer reviews as negative or positive classes, or you are a loan manager and you want to classify the loan applicants as risky or safe, or you are a healthcare analyst and you want to predict whether a patient will suffer from diabetes or not. All these examples have same kind of problem to classify reviews, loans, or patients, and this can be solved with the help of naive Bayes. Okay, naive Bayes is a simple yet powerful classification algorithm based on Bayes theorem. It assumes independence between features which might not always be realistic, but it often performs well. So if we talk about applications, naive Bayes has various applications, including spam filtering, sentiment analysis, medical diagnosis. Its simplicity and effectiveness make it a valuable tool in data scientist toolkit. Let's move to next slide. Okay, Bayes theorem and conditional probability. Bayes theorem is used to determine the conditional probability of event A when event B has already been occurred. So basically, events are of two types: independent and dependent. If we talk about probability of throwing a die and getting two, it's 1 upon 6. And if we throw the same die again, then probability of getting a 6, it's also 1 by 6. Both the events are independent, and probability of occurring 2 that is not affecting probability of occurring a 6. But when we take an example, suppose there is a bag, and inside bag there are 3 red balls and two green balls, and if we pick out the take out the two balls in first chance, and if we calculate the probability of taking out green balls, it will be 2 upon 5. But when we have taken out two balls, only three balls are left, and then we will calculate the probability of green, then it is going to affect the probability of green taking out green balls. So these are dependent events. Now, the general statement of Bayes' theorem is the conditional probability of an event A given the occurrence of another event B is equal to the product of the event of B given A and the probability of A divided by the probability of event B, as we can see in the image given below. So here P of H is the probability of hypothesis S being true regardless of the data. This is known as the prior probability of H. And P of D, the probability of the data regardless of the hypothesis, this is known as the prior probability. And P of H given D, the probability of hypothesis H given the data D, this is known as the posterior probability. Now let's move to next slide. Okay, so let's have a look at the implementation of the naive Bayes. This is the sample code. First, we are going to generate the data set. So here from scikit-learn datasets import load iris. Load iris is a sample dataset of 150 samples of iris flowers. So here we are going to uh, take one variable x and y. Y contains the features and y contains the target variable, and x is going to contain the features. Now we will split the data into training and testing sets using train test split, which is from sklearn.model selection import train test split. Then we are going to create a Gaussian naive-based model using Gaussian NB, which is class imported from sklearn.naive-base. Then we are going to train the model on training data using model.fit and passing the values xtrain and ytrain. Then making predictions on the testing data using model.predict. And then we are going to calculate the accuracy of the model using accuracy score and printing the accuracy. So let's copy this code and paste it on Jupyter notebook. Okay, you can see the implementation of this code. We are generating the iris data set and then splitting the data into training and testing sets, then creating a naive-based model, then training it, and then making a prediction based on it. Now let's run this code. Now you can see that we got the accuracy of 1.0. Now let's move back. Okay, so types of naive-based classifiers. Basically, these are of three types. First one is Gaussian naive-based, which we used in the above code. It assumes that the features follow a Gaussian distribution It is suitable for continuous data. Multinomial naive Bayes, it is used for discrete data, particularly in text classification, where features represent the frequency of words in documents. Bernoulli naive Bayes, similar to multinomial, but assumes binary features, whether a word occurs or not. And applications include text classification, commonly used in spam detection, sentiment analysis, and document categorization, and medical diagnosis, helping in predicting diseases based on symptoms. Okay, so that's it for now. मिलते हैं अगली वीडियो में. Till then, keep learning and keep exploring. And thank you for watching.